You should have at this point watched the CPPS bonding video on page 7 for day 2 and completed the guided notes or questions for that. There were 20 questions, and you've also been asked to work on page 8 on the right side, the column 1 and 2, questions 1 through 14, drawing the Lewis dot structures as practice for approximately 10 minutes. So far you have about 27 and 28 minutes into the class period. So this one may get broken up in little separate sections because I'm worried about time. So I may break it up and I'll be monitoring time as we go. So we are currently on page 7, middle of the page on the left side where it says chemical bonding. So we're looking at what is a bond and why. A bond is a force that holds atoms together. Why do they do this? They need to obey the octet rule, meaning filling that 8 electrons around the outermost shell or 0 electrons around the outermost shell. And they do that to be stable, to be more like a noble gas. When atoms bond, they are both attracted to the valence electrons. We can use Lewis dot diagrams to show how items bond. There is a crash course video that you can watch after you're done. The link is available in your packet, and the video is also uploaded onto Schoology. Electrons can be gained and lost to a bond. We talked about that one a little bit. We showed anions and cations. Electrons can also be shared. Keep in mind, during all bonding, we are talking about valence electrons are involved in the bonding process. So we gain or lose electrons, we can share electrons, and the electrons we're talking about are valence electrons. We have different types of bonds, and we are now on page 9. You should already have glued in the foldable for metallic bonds at the top on the left side, covalent bonds on the bottom on the left side, and then I believe ionic bonds was on page 12 for day 3 at the top left. Another video I'd like you to watch, but I don't want to interrupt the notes, is the atomic bonds video. It is also available on Schoology. It would be a good summary to use to watch. Once again, addressing the 3 types of bonds, and then you should be able to describe each one after the notes as well as watching this video. The expectation is you will watch the video. So the first bond we're going to look at is metallic bonds. So make sure you label the front of your foldable on the top of page 9, metallic bonds. And we're going to open that up and take our notes. Due to metallic bonds, we have metals as well as alloys. So the valence electrons of metal atoms tend to be weakly held together to the atomic nucleus. So they're just hanging out there, but it's a pretty weak attraction. The loose electrons taken off the metal atoms causes metal atoms to be bonded together to form alloys. So it's really a mixture of 2 or more metallic elements. So these guys are hanging out, the electrons are hanging out. They are not attracted very well to the nucleus, so they allow to hang out with other atoms. And it can be other metals. There's not too much on this. That's it. Covalent bonds. We're going to be here for a little while, and once again, we may have to break off to a separate video. This is only slide 9, and we've got 21 slides to go. So covalent bonding, You should have that titled for your graphic organizer. I did put a header there. I don't know why I did not do that with the metals, but I did do it for covalent bonding. But if you glued over that, then please put covalent bonding on the front of your foldable for page 9. Covalent bonding, keyword here, sharing. This is where we share electrons to obey the octet rule. Both atoms' nuclei are attracted. It contains two nonmetals. So you have a nonmetal bonded with another nonmetal. For short, we call it a molecule. So for an example, we can have chlorine attracted to another chlorine, or we can have hydrogen attracted with oxygen. Both of those examples only use nonmetals. The nonmetals are held tightly by effective nuclear charge, or ENC. Neither nonmetal is willing to give up its electrons. They must share electrons to become stable. The atoms are held together by the effective nuclear force or charge between the shared electrons and the two atoms' nuclei. So once again, we're talking about sharing, sharing, sharing. That's the big guy here. Some of the properties that we have. Covalent substances are usually soft, like chalk, so think about that. They're usually poor conductors, which means they're great insulators. They have low melting and boiling points. So for an example, we have a lot of gases. Water has a low melting point and also a pretty low boiling point. They can exist as solids, and we're talking about at room temperature. So we have carbon dioxide as a gas, we have alcohol as a liquid, and we have all sorts of things that are solids. So we have various states. We have solids, we have a lot of things that are liquids, and a lot of things that are gases at room temperature. To keep in mind for in the future, ionic substances, pretty much all of them are solids at room temperature. So all the things around us, a lot of things are covalent, covalently bonded, and we have different states. Another thing to think about are some examples. We have wool, cotton, carbon dioxide, water, and wax are all common examples of things that are formed due to covalent bonds. All right, so we have some diagrams here. I'm not expecting you to draw these. If you notice, I don't have any spaces on the white or on the pink paper to do this, but you can draw them on the white paper if you want, on the front. That's perfectly fine. So we have hydrogen and fluorine, and this is using Bohr models, which is really annoying. So that's why I'm telling you don't have to draw them. Where you have one dot for the hydrogen or one electron, and then the outermost shell, we're looking at the blue ones for fluorine, there are 7. And we can draw those really close together so they look like they're connected. We'll do this in a more simplified way in class. I will be doing an extra video for that using the DocuCam. Carbon dioxide, showing carbon there on the bottom center, having 4 blue electrons there in the outermost shell. And then oxygen has its 6 electrons floating around in that teal. So different types of bonds going on there. We have the shared electrons between a carbon in each of those oxygens. So we'll also be drawing that in our notes using the DocuCam. So the next thing on page 9 is slide 14. So which of the following would form a covalent bond? Keep in mind the key there is, do we have a metal or an ion? So ions have charges. So letter A, has two hydrogens, both of which are nonmetals. Letter B, we have sodium and chlorine. Sodium is a metal, so therefore not covalent. Letter C, we have oxygen and fluorine. Both of them are on the right side of the periodic table. It's easier to just look at the right. There's only about 12 elements that we work with, and both of them are there, so that would be covalent. Letter D, sulfur and chlorine. Check to see if they're both on the right side of the periodic table. They should both be there, so that should also be covalent. Letter E, barium. He's not on the right side of the periodic table. He's one of those weird metals. He does make pretty colors, so that is ionic. Letter F is nitrogen and hydrogen. Nitrogen is on the right side of the periodic table. Hydrogen, unfortunately, is at the top left, but keep in mind we said he was an exception to the alkali metals. He's really not a metal, he's just there because of valence electrons. So that guy is also covalent. Letter G, we have NH4 plus. That plus tells us we have an ion, so that guy's going to be ionic. Letter H, we have iodine and nitrogen. Both of those are on the right side of the periodic table, so that will be covalent. And letter I, carbon and oxygen, both of those are also on the right side of the periodic table, so that will also be covalent. All right, the slide 15 is where I think we're going to stop for time because we're pushing 12 minutes, will be our next video.